Hello everybody! I'm very happy to see you again. In the previous videos we were talking about science and its methods. Another interesting topic to continue is related to techniques and technology. They have been playing a great and important role in our society for a long time. Knowing and using techniques and having technology handy give extreme advantage over others and allow to achieve results more efficiently and faster. Results can be achieved in your personal everyday life and life of big organizations. In some cases, without knowing technology, results cannot be achieved at all. Let's try at the beginning to discuss basic terms and their meaning to have a starting point for current video talk. When you read about science and technology, you can see how interrelated they are. These terms sometimes are mixed and no well borders are clearly seen between them. Let's check these borders now. A lot of technological achievements are based on scientific research, like for example turning electromagnet into a device that made the electric motor, or using electromagnetic waves for communication. On the other hand, invention is not necessarily limited by the extent of scientific knowledge, meaning can use science a little bit, or may not be based on scientific knowledge at all. It may be just a matter of lots of experimental empirical attempts with eventual results, which are technological inventions. Moreover, scientific advances may have been derived from technology. Some examples are mechanization of time by medieval clockmakers, which preceded the scientific revolution of the 17th century, the rise of thermodynamics and the concept of energy. Another example, huge and strong medieval cathedrals buildings were designed without the benefit of established theories of structures and strength of materials. They relied on accumulated practical knowledge and their own intuition. Another example, Marconi succeeded in transmitting radio signals across the Atlantic when science would have ruled it out as impossible that time, which led to new scientific knowledge. So science and technology live side by side. They both need to answer some old philosophical questions raised even by Aristotle. What is it? What is it made of? Who or what made it? And what is its purpose? The emphasis on purpose marks a distinction between science and technology. From previous videos about science, we remember that from high altitude, science is the human activity field aimed to form and systematize knowledge about the reality. Science eventually wants to have properly working hypotheses. They need to be based on rationality, truth, objectivity, and realism, as we discuss in videos through science lenses. Funny part in science is that results of a research may be unpredictable and unexpected. We discuss inductive logic in the videos Methods of Science, about science moving from observed to unobserved. Science can be pure science, an activity without clearly seeing practical final goal from the beginning. For example, Dalton's atomic theory was made accidentally. There were no plans to discover it. At the beginning, they could not have foreseen the outcome of their researches. The technologist, the inventor, on the other hand, almost always works towards a foreseeing objective. It would be difficult to imagine how an engineer setting out to design a new type of bridge or build a revolutionary new heat engine could end up producing a new type of ship or freezer. Technology is purposive, and criterion for this purpose is simple. Does it work as preliminary planned or intended? Technological working hypotheses need not be correct. It only required to be practical. So we just clarified where is the border distinction between science and technology. Move on to the next topic and talk about our purposive practical working activity. Technology. Let's make this topic wider. It would be actually better to talk about techniques as well. Techniques and technology are closely related to each other, talking about the same things often, even though in some cases they are perceived separately and people apply them in different situations. Term techniques came earlier, and then technology came. What are they about? Once we have a problem, we need a solution, and it may come in form of technique. We have a technique of the painter's brush strokes, or horsemanship, or navigating an airship. Always it's a matter of purposive, effective activity, never of things. Transport, for example, have developed out of the ideas of driving and rowing, sailing and flying, and not out of any concept such as that of wagon or of a boat. Let's remind few historical moments now to understand how both these terms joined and accompanied people on Earth. That would allow to clarify their meaning and difference between them. 3 periods mentioned in books to historically discuss technology and techniques. The first period in development of techniques up to 7th century and the rise of modern science. The second period is Industrial Revolution. And the third period is a story from mid-19th century to present days. Let's start first important period of time, development of techniques. And we'll go with survey of early techniques. For every live creature, certain techniques, namely biological built-in instincts, use as tactics of living. The most important purpose for such techniques is to survive. They are genetically come from parents to offspring. They are predetermined and not alterable, and also impersonal, so any animals and humans have the similar instincts for their group. On the top of such genetic techniques, people invented handmade human techniques. The unique fact about human invented techniques, on the contrary to biological instincts, that it is independent of the life of the human genus. Techniques in man's life are conscious, alterable, personal, inventive. They are learned and could be improved. Man has become the creator of his tactics of living. Amazing thing happened long time back. Technical process was divided. The making and the using of the tool became different things. There is a technique of violin making and separate another of violin playing. Similarly, there is a technique of shipbuilding and another one of sailing, and so on. Making tools improved human survival skills and lifestyle. No other preying animal even selects its weapon. But man not only selects it, but makes it according to his own individual needs. With this, man comes into being. He has made his active life to a large extent free of the conditions of his body. Next step in human evolution brought another significant technique. It was figured out a huge need for collective doing things by a plan. That requires a lot of coordination and interaction. And specific prerequisite needs to be in place for that. You probably guessed I'm talking about language. We discussed earlier a separation of 2 techniques, making and using a tool. Along with language, it came another separation. Whenever man needs to verbally coordinate activity, technique of consciousness thought itself was separated from an activity of making things by hands. So we can use language just for thinking purposes. When talking about historical examples of techniques, it's probably easier to be focused on activities related to making tools or instruments. Discussion about early techniques started with division of labor. For example, there are known Stone Age factories for the manufacture of stone tools. Archaeology and documents, when available, proved that over the time, higher human skills were slowly achieved. Know-how of certain techniques became available for a limited number of people. For example, in metallurgy. And in metallurgy, there must have been some system of learning or of apprenticeship. Techniques of which stone to find, what exact high temperature to use for making metal, etc. Such non-obvious knowledge was given from master to apprentice. What other important techniques we can find in the history? Ancient Greeks made astronomy into a science more than 2000 years ago, with all the institutional features of science, such as cumulative acquisition of knowledge from generation to generation. This is about developing system of learning. Regarding techniques, Greeks' astronomy, like any progressive science, was accompanied by the invention of manufacture of scientific instruments and tools. 1200 years ago, in the 800s and onward, the 2 main areas of European techniques were northern Italy and southern Germany. Together, these areas form what we may call the region of Alpine techniques. Medieval German technicians were particularly active in mining and metallurgy, and this probably accounted for German excellence in the closely related science of chemistry, an excellence that has continued up to the present day. Italian techniques were associated with art, architecture, and mechanics. Agriculture is the basic industry, and here medieval Europe saw two important innovations more than 1,000 years ago: the rotation of crops and the wheeled Saxon plough that enabled heavy, fertile soils to be cultivated. One invention of the period to be discussed is social and not a mechanical invention. It's the invention of mass adult education. We cannot date the foundation of the first universities. They evolved gradually from small groups of scholars who gathered around cathedrals or cathedral schools. Then it came time of Avalanche-like use of techniques and technology, continuing till nowadays. We will talk about difference of techniques and technology later. Avalanche-like means that one invention helps to bring another one. Consequently, next one comes, and so on. Let's take an example of Johann Guttenberg's printing press from 15th century. Remember from our video about science, his press revolutionized the publication of books with a 20-fold increase in productivity. If you think for a while, you may realize that before any printing of books could appear, several inventions had to be made. Relatively cheap and effective raw material, paper. Printing ink to be developed. The press had to be adopted, probably from ancient art of winemaking. The Roman alphabet had to be in common use. Yes, it was universal for Europe with its 26 letters that time. Then it came scientific revolution period approximately from the middle of 16th century till almost the end of 17th century. The scientific revolution helped in understanding some terms and concepts in regards to techniques as well. When we discussed about borders between science and techniques earlier in this video, purposive activity was the main key. And we pointed out that some techniques and inventions can be developed without use of science. Because of technological working hypothesis need not be correct, it's only required to be practical. You probably know the word empirical, which means something based on experience, observation, or collected facts about the reality. So during scientific revolution timeframe, it was Francis Bacon who initially distinguished between science-based and what we may call empirical-based inventions. In the first category, we should today place the gas turbine, computers, plastics, television, antibiotics. They are science-based. In the second category, things like barbed wire, the zip fastener, the sewing machine, the lawn mower, and the revolving door. These inventions from second category were made without any science underneath. How to estimate, quantify that technique allows to build several times more powerful machine or process. How to compare effectiveness. Galileo Galilei was an able mathematician and gifted musician, studied at Pisa University, and he usually is credited only with inventions of thermometer, the pendulum, and the astronomical telescope. But he also came up with assessment of machine's performance, concepts of work, power, and energy. So people since his time and onwards had metrics to calculate and compare how powerful instruments, tools, machines could be. Let's wrap up with the first period, development of early techniques up to the 7th century. And let's move to the second period, Industrial Revolution. Now it's the right time to discuss differences between two terms, technique and technology. And after that we can discuss importance of this period. The term technique is applicable to human life since the very ancient times, while the term technology was coined in the 17th century, only at the time of Industrial Revolution. Technique is a procedure, purposeful activity that allows to accomplish a task based on skill or ability in particular field. We can also say that technique is a skillful, efficient way of doing or achieving something. And efficiency is applicable to lots of things around us. For example, in boxing, how to punch stronger, in selling techniques, in creating websites, based on previously proven techniques of creating attractable newspapers, etc. Technology, on the other hand, is a wider term. It usually, not always though, refers to use of science and industrial tools. That's why term technology came during Industrial Revolution and the era of manufacturing. Technology includes lots of things. Technical methods and techniques in the first place, as well as skills, procedures, organization, industrial management, tools, raw materials, and resources to produce desired products, to solve problems, to fulfill needs. Funny historical fact is given in the literature. The meaning of the word technology in its modern way, which we mentioned, came to the US from Europe later in the early 20th century. That time, Thorstein Veblen, Ray Bain, and other American social scientists translated ideas from the German concepts. In German and other European languages, a distinction existed between technique and technology. That was absent in English. In English, both terms were translated as technology those days. Just FYI, often, not always though, technology is a consequence of science and engineering. Science is the human activity field aimed to form and systematize knowledge about the reality. Engineering is a goal-oriented process of designing and making tools and systems to exploit natural phenomena for practical human needs. Often, but not always, using results and techniques from science. Funny thing that I work as an engineer for so long time and just recently clarified meaning of engineering for myself. You can realize how complex technology can be if you would visit the most sophisticated manufacturing of aero or space products. You can visit NASA Museum near Houston, Texas. It's very impressive and open to everyone. I was very lucky to visit Boeing Company's family event in 2018 in Everett, Washington, just because our friend works there. We were walking inside the world's biggest manufacturing hangar, where popular models of airplanes are assembled, like Boeing 747, 787, and others. There are so many airplane parts, details, sections can be seen there, each with their own purpose. I cannot imagine the level of logistics such manufacturers should be facing every day, not to mention sophisticated technological processes and state-of-the-art materials used. Now let's return to the second period of technique and technology development. There were several changes that radically affected the technological process. Surprisingly, we won't talk about manufacturing at this moment. The first thing to talk about is improving of a patent system. It's the idea of progress appearing in law. No more need to hide inventions, but to spread them instead at a higher pace. Inventions can become public and being useful very fast. With the arrival of patent system, the inventor became public figure. England was the first in the world with its Statute of Monopolies of 1624. They practiced granting patent letters to an inventor or innovator in general. Such letter safeguarding innovator's monopoly of his invention, innovation or craft that he had imported from abroad for initial 21 years. In 1790, USA instituted its own patent laws. Then France adopted a patent system inspired by the English Statute of Monopolies. It was not until the middle of the 19th century that a still fragmented Germany began to set up a system of the protection of inventors. What else expedited innovation? Journalism began in the 17th century. We already discussed it in the videos about science. In 1631, Théophraste Rondeau launched the Gazette de France in Paris. It was followed by the London Gazette in 1665-1666. Two other journals were about science and technology. Journal des Savants, founded in January 1665, and the Philosophical Transactions of the Royal Society, founded 3 months later. We also discussed the appearance of the first true encyclopedias, John Harris's Lexicon Technicum or Universal English Dictionary of Art and Sciences in 1704, and Ephraim Chambers's Encyclopedia or Universal Dictionary of Art and Sciences in 1728. With patent system and information publication channels in place, now we can talk about industries rapidly growing during Industrial Revolution timeframe. It started from England, and in short, industries related to textiles, coal, iron, and railroads were on a rise. Let's look into a few examples. Antoine Parent published his scientific study in 1704 about power, which can be derived from steam of water. There were lots of other following studies published, for example by Otto von Guericke about invention of the air pump, by Thomas Savery with his patent for a steam engine. There was also Dennis Papin with his invented pressure cooker and suggested on paper cylinder and his steam engine. And eventually Newcomen and his assistant John Colley in 1712 built the first successful steam engine in the world. Which ideas they were inspired we cannot tell for sure, but this is an example of the power of publications discussed earlier. Textile industry came with John Kay's invention of his fly shuttle in 1733. In 1738, Lewis Paul and John Wyatt patented a spinning machine. Richard Arkwright patented water frame in 1769. The textile revolution of Ray, Paul, Arkwright, and others indicated the potential of mass production industry. It created enormous wealth based on high productivity and stimulated innovation and invention in a number of other industries. An indication of the growing cheapness of cast iron was the introduction by Richard Reynolds in 1763 of iron L-section rails for the tramways that linked coal mines with rivers, canals, and ports. From the middle of the 18th century to the first decade or so of the 19th century, structural engineering, power generation and transmission, machine tools, gas lighting, chemical industry, and transport all advanced under pressure from the textile industry. The first modern elevator or lift was the byproduct of structural engineering made possible by multi-story textile mills with power delivered to the door. William Hadley, Timothy Hackworth, and George Stephenson with his son Robert transformed idea of steam locomotive running on iron L plates into the railroad system that was to change the world. The first railroad to carry passengers was Surrey Iron Railway, opened in 1803. The carriages were drawn by horses. In September 1825, the Stockton and Darlington Railway was opened. It was about 28 kilometers or about 17 miles long. Passengers and freight were carried by locomotives and horses. I also want to mention that the first 3 decades of the 19th century were a time when, beginning in France, science was organized into something like the structure we know today. Early steps of electrotechnology appeared in 1831 when Michael Faraday at the Royal Institution in London discovered electromagnetic induction. Faraday's discovery led almost immediately to Hippolyte Pixee's invention of the magneto-electric machine, or magneto, by which electric current could be generated mechanically. We mentioned discussion of the second period of development techniques, now with technology, during Industrial Revolution, with the most significant inventions and industries examples. What we have discussed so far? We put borders between science and technology, with purpose working as the main distinction. Does it work as intended is the main question for a technologist. Then we mentioned 3 historical periods in regards early techniques and technology, and deeper discussed first 2, development of techniques up to 17th century and period of Industrial Revolution. The first period was about handmade human techniques of making and separately using tools. Then human language as a technique, followed by system of learning and apprenticeship. And some applied areas were mentioned, like mining, metallurgy, architecture, mechanics, agriculture. Avalanche-like use of techniques and technology with an example of Guttenberg's printing press was mentioned, as well as scientific revolution and inventing concepts of work, power and energy for assessment tools performance. For the second period, Industrial Revolution, we touched how wider term technology is compared with term technique. Patent system and journalism help to expedite innovation with an example of way to first successful steam engine. We mentioned mass production industries like textile industry, cast iron production, structural engineering, power generation and its transmission, machine tools, gas lighting, chemical industry and transport. We will continue with third period of development techniques and technology in the second video. Hope to see you there.